Solving recurrence relation through substitution method. Suppose we have this recurrence relation. So how we are going to solve it? We are going to solve it. Tn is equals to t n by 2 plus n. Now next what we will write? We'll write t n upon 2 square plus n by 2 plus n upon 2 to the power 0. For n we can write n upon 2 to the power 0 because 2 to the power 0 will be 1, so it will be n. Next what we can write? We can write t n upon 2 to the power cube plus n upon 2 square plus n upon 2 plus n upon 2 to the power 0. Like that, if we go by k time, then what we will get? We will get t upon n upon 2 to the power k plus n upon 2 to the power k minus 1 plus n upon 2 to the power k minus 2. Like that, we will get n upon 2 to the power 1 plus n upon 2 to the power 0. So we can write like this: t n upon, as here it is clear, we can suppose n upon 2 to the power k is equals to 1. So n is equals to 2 to the power k. If we take log, so what we will get? Log n base 2 is equals to k. So from here we can write this: n upon 2 to the power log n base 2 instead of k. So log n base 2 plus n. Now we start from here. Instead of start from here, we can write start from here. So we can write like this: 1 upon 2 to the power 0 plus 1 upon 2 to the power 1 and so on. 1 upon 2 to the power log, instead of k, what we can write? Log n base 2 and minus 1, so minus 1. So now we can exchange it. As we know, we can exchange this by this, n by 2. This is a formula. So what it will be? It will be n upon n log 2 base 2. This n will be replaced by 2. So n upon, we can write like this: 1 upon 2 to the power 0 plus 1 upon 2 to the power 1. Like that, we can write 1 upon 2 to the power log n base 2 minus 1. So what it will be? Log 2 base 2 will be 1. So n divided by n. So what we will get? Log 2 base 2 will be 1, and so this will be 1, and n divided by 1. So what will left? 1 only. And here, this is the GP series. This is the GP series. And here r 1 by 2. It means r is less than 1. So formula will be a 1 minus r upon 1 minus r. This will be the formula. So what we can write here? n 1 from here, 1 minus 1 upon 2 log n. Instead of log n minus 1 base 2, we will take log n on 1 minus 1 by 2. So because this is decreasing order, so its value will be equals to 0. Because this is in decreasing order, so its value will be equals to 0. So we can consider it as a 1 plus n 1 minus 0, because decreasing and its power is log, so value approximately equals to 0. So we will consider it as a 0. So 1 minus 0, 1 minus half. So this will be approximately equals to So this will be approximately equals to n. So we can simply say order of n. So by substitution method we find that the recurrence relation complexity is order of n. So this is the way we can find out the order of any recurrence relation through substitution method.